In the previous video, we have created a couple of scripts in our AI folder, and we have implemented the AI action data and AI movement data. Now, what is left is to implement the AI decision, AI state, and AI transition before we can implement the concrete decisions, states, and transitions so that we can implement our enemy AI. And I have forgotten to implement one more script, so let's right-click, create C# script, and we will need AI action. So the idea behind this is that AI state will represent the general state, but the actions will be what should happen when we go into the state. Okay? So first of all, we are going to start from creating this action. So let's open up the AI action script. Okay. Let's delete the update and start methods. What we will need to do here is we are going to create protected AI action data. And let's call it AI action data. Okay. We will need to have protected AI movement data. And let's call it AI movement data. And we will need to have the access to our enemy brain. So protected enemy AI brain, and let's call it enemy brain. Okay. We will need to get the reference to all of those. So awake, and we are going to call AI action data equals, and we are going to create a structure that our enemy will have a game object called AI, which will store the AI action data and AI movement data. So what we can do is to access that this concrete component, and we know that this will be the child of the root component or root game object called the enemy. We will search for the transform. Next, we are going to access the root, which is the topmost transform in the hierarchy. So this will be the enemy game object. And then we are going to call get component in children, and this will search the first layer of children of this component. So this will search for the AI game object that we will create soon, and we are going to get here the AI action data, and this will be how we access this. We can copy this statement because it's pretty long, and instead of AI action data, we are going to get AI movement data. This in the same way we are going to access, instead of AI action data, AI movement data component. Great. And last thing that we will need is the enemy brain. So enemy brain equals, and this time we are going to get it from the topmost component because our enemy game object has the enemy brain. So again, transform dot root, which is the enemy game object, that is topmost object, dot get component, and we are going to get the enemy AI brain. Great. And since this will be the abstract class, we are going to add here the abstract keyword before the class definition, and we are going to create public abstract, and this will be void take action. So any action that we want to implement will extend this AI action class, and we'll have the access to those components, and we'll need to implement the take action method, and we are going to simply loop through each action inside our state component, and we are going to call on each action take action to perform the action that we want the agent to perform. And before we exit this, we will copy those statements of the AI action data, AI movement data, and enemy AI brain and the awake function. We could extend it as a abstract class, but I think it would be too complex. So we are going to simply copy this code, but I think there could be a better way to structure this code. Let's copy those three statements and the awake function, and let's go back to Unity. Great. And what we will want to do is open up the AI decision script. Great. Let's delete the update and start. We can Ctrl V to paste our AI action data, movement data, and enemy brain fields. And we are going to make this class into an abstract class. And again, we are going to simply add here a public abstract and bool make a decision. So this class will be responsible for example, asking the question, is player in range? So this question is answered by the bool value true or false, and this is what we will have. And if we want to save some more complex data, we can always add fields to our AI action data and AI movement data and store the position or some sort of data inside those data classes. Make sure you save the class, and let's go back to Unity. We have 2 more classes to implement. Let's start from AI transition. Let's open this class up. Great. Again, delete the update and start. And AI transition will not be the abstract class, as well as the AI state will not be the abstract class. We are going to use those to store the references. In the transition, we will want to have prop, tab. Let's type list of AI decisions. And this will be the list of the decisions that must be considered before we can move to one state or remain in the same state. So if we can create decisions for our idle state to the chase state, the transition will ask a couple of decisions like, is player in range of our detection circle, and if is player visible. So those will be the 2 decisions, and we are going to simply add those decisions to our list. So let's move to the name of this, and let's call it decisions. Enter. Let's implement another property. So prop, tab, and let's type AI state, and let's change it to positive state or positive result. Okay, and we can copy this, paste it below, and let's name it negative result. So the positive result state will be the state that we transition to if the decision is positive or all the decisions in the list returns the positive values, and negative result will be what we do if one of those decisions failed, so we did not meet one of the expected conditions to move to the positive result state. And let's add field, serialize field attributes to all of those so that we can set them in the inspector, so to the list, to the AI states as well. And this will be it for our AI transition file. And let's move to the last file, which is AI state. So let's go back to Unity. Okay, let's open up the AI state script. Great. Here, let's delete the start and update. We are going to implement them when we need them. Again, this will be the default class. It will not be an abstract class, since this will only store the references to our AI actions and transitions. And of course, we will need to have the reference to our enemy AI brain to transition between states, since the enemy AI brain will hold the reference to the current state that we are in. So let's create private enemy AI brain. Let's call it enemy brain. And let's set it to be null. We can leave it as the private field, since we are going to get the reference to it anyways. Next, let's create private list of AI actions, and let's call it actions equals null. And last one will be private list of AI transitions, and this will be transitions equals null. We should use lowercase letters for those. I'm just used to implement the properties, but we can use fields as well here. And we want to expose those, so let's add a serialize field to the list of actions and to the list of transitions. Great. Again, we will need to get the reference to our enemy brain, so let's create awake, and let's add here enemy brain equals, and we are going to call transform.root, and we are going to get component in the root, so the enemy game object, and we are going to type enemy AI brain. Great. So last thing that we will need to do is we will need to make use of those actions and transitions that we have. So what we can do here is we are going to call update state, so public void update state, So this will be different from the update for Unity, the default update function. And the idea is that this will be called inside our enemy brain script. And depending on the state that we are in, there will be different actions and different transitions, and the result will be depending on what we put in those lists. So this will make our system more modular. What we should do here is, first of all, we will want to call all the actions that are required for the state to be made. So for each, tab to create this from the snippet, tab to move from the var type to the item, let's call it action, tab again to move to the collection, and we are going to call it actions. So this will be our list of actions, and for each action we are going to simply call action.take action, since each and every subclass of our action type will have this method. So we are ensuring that we are calling each action. It doesn't matter what it does, the action, we only want to call it. Next, we're going to call for each tab var tab again, let's call it transition, and let's tab again to call it transitions. Okay, and here we are going to make sure that we call each transition before we decide if we should go to the positive state or negative state. And the idea behind this will be that the transition will be ordered. So what transition will be first on the list will decide if we should go to the next state or stay in the same state. And depending on the transitions, we are going to be able to assign, for example, idle state as the positive result, and we are going to first check if the player is player in range, and if it is true, we are going to transition back to idle, and in our script we are going to simply do nothing if we want to transition to the same state. So we are going to be able to move to the next transition on our list and check, for example, player visible. So there is we are shooting a ray and we are checking if the player is visible. And if the player is visible, we are going to return true, which will transition us to the chase state. And now we are going to change the state and call again the for each loop to take actions, and then again for each loop to check the transitions. Okay? So the simplest way we can implement it is we are going to call bool result, set it to false. Next, we are going to call for each, again, for each var decision, tab again to the transition. So this is the transition that we have here in the for each loop dot decisions list, and we are going to call simply result equals our decision dot make a decision. Okay, and we are going to check if result equals false. Then we will know that we need to break from this for each loop, since one of the decisions doesn't meet the criteria for the transition, so we know that we want to return false. And then we are going to check if result, so if the result is positive, so all the decisions inside our transition were met, we can call if our transition dot positive result is not null, we are going to call our enemy brain dot change to state, and we are going to call transition dot positive result. Since we do not have this inside our enemy brain, let's alt enter on this method and generate it in our enemy brain, and we can simply return here. Great. And else we are going to check the same if our transition dot negative result is different than null, because at some point you might forget to assign it, so this will cause an error. We are going to call enemy brain dot change to state, and we are going to call transition dot negative result, and again we can call result. So this will give us the opportunity that if we do not assign any result, we are going to simply skip this and go back and check the next transition. So for example, if in this case we will simply return true, but we will not move to the next state. Now this can cause an issue if you forget to assign the positive result and negative result in case you wanted to have one. Yeah, I suppose this architecture could be improved. Okay, it was a lot of code. Let's go back to Unity and check if we do not have any errors. Okay, it seems like we are good to go. So in the next video, we will start implementing the concrete actions, decisions and transitions and states so that we can implement our enemy behavior. So see you in the next video. In the previous video, we have implemented our basic classes, part of them are abstract, for our AI system. Now, in this video, before we start implementing the concrete classes for the decisions and for the, I believe it was actions, we will need to create our preset for our enemy so we can have a visual way to represent our AI system, as well as we will need to update our enemy AI brain because we have added one method change state to it, but we have not implemented it, so we will need to add some code here. So let's start maybe from implementing a structure for our enemy chart, the AI structure. So what we will need to do is in the hierarchy, select our enemy chart, and in it, right click, create empty, and we are going to create an empty object. Let's call it AI. Okay, make sure the transform is set to be position 0, 0, 0. Great. Now we have those AI movement data and AI action data, and those will be placed on our root AI game object. So let's drag them from our scripts from our AI folder. Let's add here AI movement data and AI action data. So you will be able to view here, for the debug purposes, what is going on when you click on an enemy. So we will be able to see if the enemy is attacking, if the target is spotted, if the enemy has arrived, and it will allow you to easier find if there are any bugs in your code, as well as you will have the direction and the point of interest to check against the player. So where is the player, where is the point of interest, you will exactly know what is going on. Now, to make the AI more visual, we are going to create new game objects inside our AI game object. So let's right click, create empty, and let's call it, this will be our representation of the state, let's call it idle state. Okay, we can select it, Ctrl D to duplicate it, and let's rename it to chase state, and let's Ctrl D to duplicate it, and let's rename it to attack state, since we do not have any more states. Now every one of those will have AI state on it, so let's drag AI state to the idle, to the chase state, and to the attack state. Okay, and when we implement some actions that we want to happen in those states, we are going to drag those as well on those game objects. Now we can see, we can open the AI state and we have our actions. Those will be placed here as well, and the transitions. So how we are going to implement the transitions, we will need to click on the idle state, for example, right click, create empty, and let's change the name using F2 or the inspector. Let's rename it to transition chase. So from idle, we will be able to transition to the chase state. We are going to add transitions. So let's add a transition here. And we can see that now we can add the decisions here, as well as the positive result and the negative result. So as I have mentioned previously, the positive result of idle being idle state detecting that we are in range of a player will be to, positive result will be to move to the chase state. And the negative result we will leave as none, since in our state, I think the state behavior, so let's click on idle state and those three dots and edit script. Great. If we slide down, we can see that if result is positive, we are checking if transition.positive result is not null. and if it is not, we are transitioning and returning from this function so that our enemy brain can load a different state and perform the update state function for this new state. Now, if we do not assign this result, it will go and loop for the next transition. So check the next transition and its decisions. So this is an architecture that I have chosen. Of course, we could have checked here if we assign the idle state as the positive result or the negative result. We could check if the state is the same as the enemy brain current state that we will implement shortly. So we can improve it definitely, but for our purposes, we are going to simply leave it empty, and if this is null, we are simply not going to do anything with it. So let's go back to Unity. Okay. So again, we are going to simply leave the transition chase negative result to none, and we are not going to be able to transition from it anywhere else, but back to the idle state and again perform the decisions that are required for the transition to chase state, and we are going to continue checking it. Next, we will want to open a chase game object. Right click here and create, let's call it transition attack, and Control D and rename it to transition idle. So what we are going to do here is on our transition attack, we are going to add an AI transition, and for our transition idle, we are going to add AI transition. And if the result is positive for the transition idle, so the condition will be if the enemy is in range, we are going to return, we are going to do nothing since we want to transition to the attack state. If the result is negative, so the decision will be that the player is outside of the detection range for our enemy, we're going to drag here the idle state, and we are going to get the negative result to transition back to the idle state. For the attack, we're going to simply assign as the positive result attack, since this will simply have a decision if we are close enough to the player to be attacking him or her, and if we are going to transition to the state of the attack. And here in the attack state, let's right click, create empty, let's rename it to transition chase. Okay, again we are going to drag here AI transition, and here again we are going to simply check if we are still in range of our player, and if we are, we want to stay in our attack state and wait for the attack state to reset the delay before we attack again. And if we are not in range of our player, so we cannot attack our player, we will want to simply pass as the negative result our chase state, so we want to go back to our chase state. And what is left now is simply choose our attack state and assign our transition chase to our transitions list. For the chase state, again, we will want to first check the transition attack, so we will place it as the first on the list, so we want to see if we can already attack our player. If not, we will want to then check if we want to transition back to our idle state. So for example, our player has teleported or have some superpower to dash, and the player has exited the range of our enemy, so enemy will check if it should transition back to our idle state. And for our idle state, we are going to simply drag our transition chase as the first transition, so we're going to constantly see if we are in range of a player to start chasing it. Great! So we have our idle state, we have assigned a transition for the idle state, and can only transition to the chase state. The chase state can transition to the attack state, and we want to check it first. If not, it can also transition to the idle state, and the attack state can only transition back to the chase state. But of course, we could add more transitions here and more states and expand this AI behavior. Now, two things that we are lacking is the concrete actions that we should take in each state, and we are lacking the decisions that we should ask when we are transitioning, where we are in the checking the transitions. But before we can implement those, we will need to go to our enemy chart in the hierarchy, find the enemy AI brain, click those three dots and edit the script. Great! We are in the enemy AI brain script, and what we want to create here is, let's create prop, tab, let's set that as the type AI state, and let's move to the name and let's call it current state. Okay, enter. Let's make sure that the set is private. So we can only set it through the enemy AI brain, and let's add to it the usual attribute field, serialized fields, to expose it in the inspector so we can check what it is. So what we are going to do is we are going to slide down and create an update method. Okay. And in update, we are going to first check if our target equals null. So the reason behind it is that if we don't call our movement to stop, our enemy would still continue walking in the direction that it was given to it. So we will want to call here, if the target is null, we are going to call on movement key pressed, question mark if anybody is listening, invoke, and we want to stop the enemy, so vector 2.0. And we want to constantly remind our enemy that it should stop. Else we are going to call our current state.update state. And this will call any action that is assigned to this AI state. So for our idle state, it will just mean that it tries to call our transitions. But for the attack state, it would have an action called attack, and it would perform the attacks on our player. Okay? We will need to add here two public methods, since our enemy AI brain will direct the attack and movement. So let's create public void attack. And we are going to simply call here on fire button pressed question mark dot invoke. So if any state, which as you might recall, every state has the access to the enemy AI brain. So if any state has an action that wants to attack, we are going to call the attack from our enemy AI brain to call the on fire button pressed event. And we are going to simply need to create public void move, and we are going to pass here vector to movement direction, and we are going to pass vector to target position. Okay, and what we are going to call here is on movement key pressed question mark dot invoke. To perform the movement, we are going to pass here simply the movement direction, and we are going to press here on pointer position change. Since we want to make sure that our enemy rotates towards our player, we are going to invoke, and we are going to pass here the invoke and pass here the target position. Okay, I have misspelled it. Okay, great. So now we have those two methods that can be called by our AI states or our AI actions to actually make our enemy do something. And last thing that we will need to do is we have this change to state method. What we are going to call here is we are going to pass here AI state called state, and we want to call here the current state equals state. And of course we could add a check if the state is the same as the current state, then do nothing. But since we are still returning in our AI state, since we have this code that will return, we simply do not want to assign anything for the state, and then the code will be ignored. But of course, as I have previously mentioned, we can improve the code and make it more bulletproof. But for now, I think that will be it. So make sure that you save the scripts, and let's go back to Unity. And what we want to do is we want to select our enemy chart in a hierarchy and make sure that the current state is set to be idle state by simply dragging our idle state to the current state in our enemy AI brain. So we need to have the preset for our current state, so our agent will start in the idle state and do its thing when we implement actions. So basically that's what we are going to do in the next video. We are going to start implementing the actions and the decisions that we can assign in our AI hierarchy for the behaviors of our enemy. So see you in the next video. In the previous video, we have implemented the logic, or rather the structure for our AI, and we have added the states and transitions to our game objects so that we can have some kind of visual representation of what is going on. Now, before we can make our code work, we would like to make sure that we have some transitions, or rather the decisions for our transitions. And what we are going to do in this video, let's create some decisions that will be in regard of the idle and chase state. So we will want to make a decision if we should chase our player, and then a decision if we should stop. So what we are going to do is let's go to our scripts _scripts in the project section, to the AI folder, right click, create a new folder, and let's call it decisions. Okay, let's open this folder up, and let's right click, create a new C# script. Let's call it the distance decision. Okay, let's open this script up in Visual Studio. Great. What we will want to do here is we will want to first delete the start and update methods, and we do not want to extend the mono behavior, but rather AI decisions or AI decision class. And this is our abstract class, and it requires us to implement a make a decision method. So Alt Enter on those squiggly lines, and we can see that this has implement abstract class. So this is it. This is our method that we will need to implement. Now, the distance decision is just the decision if the distance between our enemy and the object or our target is within a range. So we are going to create it prop, tab to create it, property of type float, and tab to move to the name, and let's call it distance. Enter. We are going to add here the attribute field colon serialized field, and we are going to add here a field colon, and we want to have a range, and let's set a range between 0.1f and 10 for now. I think it should be a good range, and let's set the default range to be 5. Okay, so default distance will be 5, and it will be within a range 0.1 to 10. Now, what we want to do is in the make a decision, we need to develop a logic that will check the distance and return us a bool value of if the target is within a distance or not. Do mind that in our AI decisions, if we right click on it and go to definition, we have access to our enemy AI brain, movement data, and action data. So we will be able to access those from our distance decision. I'm going back to the distance decision script. So what we can do is we can, in the make a decision, type if our vector3 dot distance, and we are going to check is our enemy brain, which is the enemy AI brain reference, dot target dot position transform dot position. So target is our player. We are going to check its position in our transform position, since this AI script is placed on the our enemy chart, and its transform is 0, 0, 0. So this is placed at the center of our enemy chart. So we can use its position to calculate the distance between us and the target. So we are going to simply check if this vector3 distance is less than our distance. And if it is so, we are going to check if our AI action data dot target spotted is equal to false. So if we haven't spotted the target, we're going to simply call AI action data dot target spotted equals true, and we are going to return here true as a decision. Else, we are going to call here our AI action data dot target spotted equals false. So we do not see the target, return false. And basically, what we could do is actually get out this return value, and at the end return our AI action data dot target spotted. And this will return the same value. And actually, I have added this else statement in the wrong place, so we are going to type here else statement, take it out of this inner if statement and put it in this outer if statement for the vector3 distance, and this return value as well I have placed in the wrong spot, so we will want it at the end of our decision. Now, we have this logic and it should be working, but what we cannot really see is this distance. So how far is it in terms of our map? So to visualize it, we are going to create a protected we can type void, and let's type on draw gizmos. So this is a method that is implemented for the debug purposes, and it will help us to visualize the distance that we have for our detection system. So what we can do is we can type if our Unity engine editor, dot selection dot active object. So when we click in our inspector on an object, this active object will be set to the object that we have clicked. So we can simply check if this object, so the distance decision object, or the object that contains this particular distance decision, is this object. We are going to call our gizmos dot color, and we are going to set it to color dot green. And we are going to simply draw a wired sphere to visualize how large is the field of detection for this enemy. So let's type gizmos dot draw wire sphere, and we are going to pass transform dot position, since it wants the center position, and the radius as the distance. Okay, and again we are going to set the gizmos dot color equals color dot white. Since gizmos, if we leave it as green, everything will be green, and the default gizmos color is white, so we need to reset it. But basically what now we can do is, let's go back to Unity. Great, the script has compiled. What we can select is our idle state, and as you might recall, the idle state, we are going to add here actions that we want to perform. We want to click on the transition chase and add here the distance, and immediately you can see the green sphere, which denotes the range of the detection for this particular distance decision. And what we can do is we can drag this distance decision to our decisions in our AI transition in the inspector. So this will be the decision that is considered when we want to go to our idle state. And again, we want to go to the chase state and go to the transition idle. Add here the distance decision, which we can do again with the add component distance decision, or we can drag it here. What we can do is change the distance. So for example, we want to stop chasing the player only if it is out of the range of our enemy. But for example, our minimal range is less. It could be less, like something like 4. But the chase distance could be larger. So even if our enemy doesn't see the player in accordance to the transition chase from the idle state, maybe we want to keep following the player a little bit longer for some purposes, or to balance the game, for example. So this gives us a lot of control over the system. I'm going to reset those to both to 5, so we know exactly what's going on. And now we should be able to transition to our chase state. Now, before we can test this whole setup, we would need to implement an action that will be the action to chase our player. So that's what we are going to do in the next video. We are going to make sure that we can actually start chasing the player. So see you in the next video. In the previous video, we have implemented the distance decision that is shown here. So this is our circle of the decision, and we have added it to the transition to chase and to the transition to idle. So now what we would like to do is we would like to implement an action so that we can actually see the enemy chasing our player. So what we are going to do is we will need to go to our underscore scripts AI, and we are going to right click here, create a new folder, and let's create a folder called actions. Okay, let's open it up. Let's right click, create here a script, and we are going to call it chase action. Okay, let's open it up. Great. So this will be our new script, and this script's purpose will be to tell our enemy brain that we should move, and we should move towards our player or our target. So we can delete the update and start methods, and what we can do is extend not mono behavior but rather the AI action. Again, this is an abstract class. Right click, go to the definition. Again, we have the access to the action data, movement data, and enemy AI brain. and we need to implement this take action method. I'm going to go back to the chase action, and we need to Alt-Enter on the squiggly red line and call implement abstract class so that we have this take action method implemented. What we will need to do here is we will need to provide it with some logic on how to calculate what is the direction that our enemy should move and to tell our brain to actually move. So we are going to call var direction equals, we are going to type enemy brain, which is from our AI action abstract class dot target dot transform dot position. So basically this is the same what we did in our distance decision, minus transform dot position. And now what we want to do is set our AI movement data dot direction to be equal to direction dot normalize or normalized, sorry. Next, what we can do is call AI movement data and set point of interest, and we are going to simply set it to be enemy brain dot target dot transform dot position. So we want the enemy to take a look at that player or the target of it. So we make sure that our enemy is basically rotated correctly. Last thing that we will need to do is to actually make our enemy move, which we are going to do by calling enemy brain dot move, and we want to pass here our AI movement data dot direction, and we can call AI movement data dot point of interest. Now we could also call it inside our enemy brain class because it takes the data from our AI data, but we will call it here in the take action, since for me it is quite clear that if we have the chase action should call the appropriate methods to perform the chasing. So this is the chase action. Let's save it. Let's go back to Unity. Great. What we will want to do is we want to go to the hierarchy, choose the chase state, and as I have previously mentioned, we are going to put all the actions on the states. So our chase state will have the chase action. We can drag this chase action into the list of actions for our AI state script. And now we will know that we first want to start chasing the player and then check if we want to transition to each of those states, so the attack state or the transition idle. For now, since we do not have the attack state, let's reduce the transitions size to 1, and let's drag here only the idle instead of the attack state. And before we can start calling this action, we will need to implement another one for the idle state, because right now, if what we did, we have removed the attack transition to the attack state, so if we press play, our enemy will start chasing us. And it will still chase us and not stop, because now we do not have the arrive behavior to make it stop in front of our player and start attacking it. Let's choose in the hierarchy the transition chase, and you can see that the green outline depicts the area that our enemy can chase us or detect us. Let's try running out of this area. You might recall that we have set the speed for our enemy to be lower than our player, and despite that we have run away from this area, our enemy keeps on moving forward. So I have forgotten to implement the idle action, which will simply say that the movement should be 0. Stop the game, and if you have any issues with the running away from the circular area, you might want to make sure that your enemy chart in the agent movement has the movement data assigned to the custom enemy chart movement data, which has this max speed lower than the player. I think the player has 5. We can set it to 2, the max speed, so that we have a lower value so we can more easily run away from our enemy. And let's implement the second action that we will need. So let's go to in our project to the project AI actions, and let's create here a new C# script. Let's call it idle action. And let's open it up in Visual Studio. Great. Again, we can delete, update, and start. We can extend not mono behavior but AI action. We can again Alt-Enter on the idle action and implement the abstract class. And bit of a challenge here. Give it a shot. Think about how you would implement this to make sure that our enemy move function doesn't move our player. So what should we do here? And if you can, please implement the code as well. Take a look at the chase action because it will be very similar. Great, I hope you have figured it out. Let me go back to idle action script. And what I will need to do is I will need to access the AI movement data, and I'm going to set the direction to be vector 2.0. I'm going to set AI movement data dot point of interest equals, and we are going to set it to be transform dot position. So this will be point of interest will be our character, and what we will need to do is call our enemy brain dot move, and we are going to pass here the AI movement data dot direction, and we are going to pass here AI movement data dot point of interest. So let's save it. Let's go back to Unity. Great. What we want to do is go to our idle state, and we are going to want to open up our actions folder inside the project section, and we can drag it idle action onto our idle state and drag the idle state into the actions for the AI state inside the idle state game object. So now our idle state will perform the idle action, and the chase state will perform the chase action. And let's take a look at the chase state, and I can see that we have the action assigned, but for the transition to our idle state, and I don't think we have assigned the decision to transition back to the idle state. So what I'm going to do is drag the distance decision inside our transition idle inside the chase state into the AI transition. Okay, and now we should be good to go. So let's press play, and we can see that our enemy starts chasing us when we are in the green circle. You can see it better in the scene view. Of course, we can enable the gizmos here in the game view, and now you can see that this is starting to work quite fine. Now, the last thing that we will need to do is to implement our attack state, since you can see that our enemy starts to rotate in both directions and and keeps running, even if it is on top of our player. So in the next video, we will want to make sure that our enemy stops before reaching the player. So we are going to check a smaller circle distance to see if our player is in range of the attack, and then we are going to simply stop our enemy from moving, and we are going to make sure that it starts attacking our player. Great! So see you in the next video. In the previous video, we have implemented a way for our enemy to start chasing our player. And this works pretty good, but now if our enemy catches to our player, first of all, we have this issue when our enemy is rendered behind our player. This is one thing that we will want to improve. And the second thing connected with the AI is that our enemy now starts running in place when it is touching our player. So this isn't perfect, and sometimes the enemy starts rotating to the left and to the right. So what we want to do is we want to implement some actions to our attack state and chase transition to the attack state, so that our enemy will stay in some distance from the player and preferably starts attacking it. So let's stop the game. And first what we can do is we can reuse what we already have for our attack state. So let's choose in our hierarchy our enemy chart AI, and let's choose the transition attack in the chase state. Now what we have here is we do not have any decision. And lucky for us, we have already implemented the distance decision inside our scripts folder in our AI decisions. So let's drag it into our object. And now what we will want to do is we will want to decrease the distance to something like 0.8. So this will be the area, the range, in which if we reach it, so we will stay in this distance from our player, we are going to be able to attack our player. So first of all, let's make sure that our chase state has in its transitions 2 transitions, and let's add the transition 0 as the attack state and the transition 1 as the idle transition. Next, we are going to move to our attack state, and what we have is our transition chase. So it is assigned here, but we do not have any functionality to actually stop moving. So we will need to implement an action for the attack state. So let's go to our assets, to scripts AI actions. Let's right click create a C# script and let's call it attack action. Okay, let's open this script up in Visual Studio. Great. What we can do here is again remove the update and start methods and extend not model behavior but AI action. Again, we'll need to Alt-Enter on the attack action and implement the abstract class. What we will want to do here is simply we are going to make sure that our enemy stops. So AI movement data, we want it to be direction equals vector 2.0. The AI movement dot point of interest we want to set again at our player, so enemy brain, or at our target dot transform dot position, and this will be the point of interest. So our player might run around our player, but if the player still keeps in the distance of the attack of our enemy, the enemy will simply rotate around and keep on attacking. And what we want to set here as well is enemy brain dot move, and we are going to pass our AI movement dot direction and AI movement dot point of interest. And what we will want to set as well is our AI action data dot attack equals true. Okay, and we will simply call enemy brain dot attack, and this will call in turn the event on fire button clicked, and the rest will be left to the script that assigns itself or its functionality to the event on fire button pressed inside our enemy AI brain. So this will be all for the attack action. Let's save it. Let's go back to Unity. Great. What we will want to do here is choose the attack state, drag the attack action onto our state, or you can add it through the add component attack action. And let's drag this attack action as one of the actions on the list for the AI state inside our attack state game object. Okay, great. Again, we can move to the transition chase inside our attack state, drag here or add here distance decision component, and let's set it to be 0.8, so that now we will transition back to the chase state if our player has run away from the area where our enemy can safely perform an attack. Okay, let's make sure that in our chase state we are actually transitioning to our attack state, and that our attack state is actually performing the transition to our chase state if needed, and it is performing the attack action. Okay, great. And before we test our behavior, let's make sure that in our transition attack we have assigned the decision. So we need to assign the distance decision in the transition attack inside our chase state. So make sure that each of those have a decision. And again, I have made this mistake when transition chase doesn't have the AI transition doesn't have the decision assigned. So maybe to avoid this, let's open up the AI transitions, click those three dots, edit script, and here we have the mono behavior AI transition script. So let's add here awake, and what we want to do is we will want to add the decisions. So the list of decisions dot clear, and what we will want to do is make sure that decisions equals find or get components, and we are going to add AI decisions. So this will get all the components on this script, but it will return us an array. So we are going to create a new list of AI decisions. Okay, and we are going to pass here the array. And now I have made a mistake here in the spelling the list and AI decision. And now we should be good to go. So in Awake, we are going to find all the decisions attached to this game object where the AI transition lives, and we are going to assign them to the list. So no more forgetting the decisions assignment. Great. Let's go back to Unity. Okay. The scripts have compiled. What we are going to do is let's remove the decision from our transition chase in our attack state, and we are going to move our player out of the range of our enemy. So choose the move tool in the scene view and let's move our player around. And we are going to verify that our attack state transition chase have assigned the decision to itself. So let's press play, and you can see already that the decision was assigned. Now we can walk towards our enemy, and it will start walking towards us, and you can see that it has stopped. If we walk away from this, it will stop again when we reach this circular area of the possibility of the attack for our enemy. And now we can run away from our enemy. We can choose the idle state transition chase, because this is the same for the chase state, and we can run away from our enemy. Now, one thing that is left is that if we disable the gizmos in our game view, if we go towards our enemy, our sprites are all on the same sorting layer, and this can be problematic because now we can see that our enemy and our player are not correctly displayed. So we will need to fix it in the next video. So see you there. In the previous video, we have implemented our attack state, at least the part of it, but we have experienced this issue where our enemy and our player are intersecting because they are sorted on the same sorting layer. And we want to fix it. So let's stop our game. And what we will want to do is we will want to go to our folder where we have implemented our forward renderer. So I think it was the setting folder, and we have our 2D data renderer, and we have our universal renderer pipeline asset. We want to open the 2D renderer data. So because this contains all the information about rendering of our sprites. And currently at the top of it there is a transparency sort mode, which was earlier, before using the universal rendering pipeline, it was available in the project settings in the quality section or graphics section. But right now it was moved because we have selected the universal renderer pipeline asset instead of the default renderer for Unity. So if you go to assets folder, settings, and open up the 2D renderer data, you have this transparency sort mode, and we can select it, and we want to select the custom axis. And this will mean that we are going to sort the sprites that are displayed based on their position on y-axis. So now when we start playing, we are going to be able to see that the problem should be gone. It looks pretty good, but sometimes there might be an issue where your object is smaller than the player, for example, and your character is displayed here still in the background. So make sure that if you stop the game and if you go to your sprites and choose your choose your sprites for our heroes and choose the sprite editor, this pivot point will decide on how Unity is sorting our sprites. So there might be an issue where your chest, for example, is smaller than our sprite for the character, and despite our player's legs being below the chest will still be visible in front. So in this situation, move this pivot point somewhere lower around here, and then it will fix any issues that you might have. Of course, this could be fixed by preparing your sprites a little bit better to make sure that this jump is lower, and then you just cut the minimum size of your sprites. And in the right lower corner of the screen, you can see that the pivot is custom now. So you can simply modify this pivot for any of your sprites, and then it should be fixed. I'm going to remove the custom, and I'm going to choose here in the bottom right corner of the screen. I'm going to choose the center, so the sprite is so the pivot point is in the center of our sprite, and I'm going to click apply, because as you can see, if we press play, our sprite is rendered correctly right now after changing this the transparency settings inside our 2D render data and selecting the custom axis for it. Great! So we have yet another thing fixed, and we can now see our enemy or our player depending on what is our position on y-axis. Okay, in the next video we will fix our attack state, or actually finish implementing it by implementing a way for our enemy to actually perform an attack on our player. So see you in the next video. In the previous video, we have implemented a way for our enemy to chase us, stop before it reaches us, and we have fixed the issue of rendering the player and the enemy. Right now we have still an issue with rendering the gun, but we will leave it for later. But right now we have our AI setup almost working, but our enemy can't really attack our player, and this is an issue. So we are going to tackle this in this video. Stop the game, and what we are going to do is we are going to go to our scripts folder, open up the enemies, and we are going to right click here, create a create a script. Let's call it enemy attack. Let's open this script in Visual Studio. Great. Let's make it into an abstract method, abstract class. We're going to have public abstract class enemy attack. Let's delete the start and update. And what we will want to have here is, first of all, we will need to have a reference value to our enemy brain. So let's type prop, or actually we have create private enemy AI brain. Let's type enemy brain, and we are going to create awake function where we are going to call simply get the AI brain equals get component of type enemy AI brain. Great. Now, beside this, because this contains the reference to our target, we are going to call here or to create here prop tab tab. It will be a float value. Tab tab to the name, and let's call it attack delay. Okay, let's preset it to be 1 for now, and we are going to add to it a field attribute colon serialized field. Okay, and let's set it to be private set, so we will not be able to set it from anywhere else than from this enemy attack script. Now, what we will need to do is also to create a private bool wait, and this will be the bool flag if we are waiting currently for the attack to be available or not, or maybe wait next attack, or wait before next attack. And actually, let's not make it private, let's make the enemy brain and the bool value protected, because we will need to share it with any child class of this enemy attack class. Great. Now we will need to have an abstract method, public abstract void attack, and we are going to pass here int damage. Okay. And since this is an abstract method, we do not need those parentheses. We will need to have a semicolon at the end. Great. Last thing that we will need to do is a coroutine, so protected I enumerator, and this will be the coroutine to wait before we can attack. So wait before attack coroutine. Great. And we are going to simply call here wait flag, wait before next attack equals true. Next we are going to yield return new wait for seconds, and we are going to pass the attack delay, and next we are going to simply call wait before next attack equals false. Okay, great. And this will be our abstract class, and in the attack we will be able to implement a way to melee attack our player, as well as to implement some logic to shoot a bullet instead of melee attacking. And since we have the access to our enemy brain, we will be able to get the target for our player. And maybe, to make things simpler for us, let's create another method, protected game object, and let's call get target. And we are going to simply return our enemy brain dot target. So we will know that we can get the target through this method rather than getting the enemy brain itself. Okay, with this done, let's go back to Unity. Great, the scripts have compiled. We're going to right click here, create a new C# script inside our enemies folder, and let's create enemy melee attack. And let's open this script up in Visual Studio. Great. Let's delete the update and start methods, and let's extend not model behavior, but rather the enemy attack. it will be angry because we do not have the method, so Alt Enter and implement abstract class, and it will give us the attack method. And what we want to do here is we want to simply check if our wait before next attack is equal to false. And if it is, we are going to call our var hitable equals, and we will call get target, get component of type I hitable. And if the target is indeed hitable, and we are going to simply call hitable dot get hit, and we need to add a question mark before we call get hit, since we will not be sure if we have the hitable or not. We will pass the damage parameter as the damage value and game object as the object that is inflicting the damage. Great. And last thing that we will need to do is simply call start coroutine, and we are going to start coroutine wait before I think we had wait before attack coroutine. Great. So we have our melee attack. Let's go back to Unity. Make sure that you have saved your scripts. And what we will want to do is we are going to go to our enemy chart in the hierarchy and drag onto it our enemy melee attack. And now, last thing that we will need to do is to actually call this enemy melee attack. But keep in mind that our enemy script is the one that contains the data with the enemy chart data that has the attack value or damage value in it. So what we will need to do is we are going to go to our enemy script. So let's open it up by clicking those three dots or using the project view, and inside the enemies folder you have the enemy script. So let's open it up. Great, we are inside the enemy script. What I will want to do is implement the or get the reference to our enemy attack. So what we want to do is underneath the health, probably we can create prop tab. Let's type enemy attack. We are going to use the abstract class, and we are going to move to the names using tab, and let's call it enemy attack. Okay, enter. And we may want to expose it in the inspector just to see if we have the correct enemy attack script assigned. So add to it field, the colon serialized field. And now what we will want to do is we will want to actually get this. So let's slide down and let's create a wake function, and let's call enemy attack, or rather we are going to call if our enemy attack is not assigned by our player. So if it is null, we are going to call enemy attack equals get component, and we are going to get the component of type enemy attack that is present on our component. And that will be it. So thanks to the setup, we will be able to assign by hand the enemy attack. So maybe we do not want to have this on our enemy, rather we want to have this on a weapon, and we are going to simply get this attack, enemy attack, from the weapon instead of from the enemy. But for now we have the melee attack only, so this will be the way we want to assign it. And next, what we will want to do is slide down, and we will want to create a new method, public void perform attack. And this method will be assigned to our onFireButton event. And what we will want to check here is, first of all, if our enemy is not dead. So to do that, we will need to implement a new field. So maybe underneath the enemy attack, we are going to create private bool dead equals false. Okay. And now we can use this Boolean flag to see if we are not dead. So if dead. If we are not dead, we are going to call enemy attack dot attack, and we are going to pass enemy data dot damage. Great. And what we want to do is let's update the logic for the get hit. So what we are going to do is we are going to create if at the beginning of this get hit method, if dead equals false, and only then we are going to call the coroutine, and we are going to call the health minus minus. And of course we will need to make sure that if our health is below 0, we are going to call here dead equals true. Okay, great. So this bool flag might not be very useful right now, but it will become very useful when we want to add some feedback or some visual feedback like shader to our enemies. And for this, we will want to simply disable the attack option so our enemy is just standing idly while being dissolved, and then it will become invisible. Okay, so let's save it. Let's go back to Unity. Great, we have some errors. So I have misspelled the false in our enemy. Let's save it. Let's go back to Unity. Great. What we will need to do is we will need to assign our enemy chart, the enemy AI brain, the fire button pressed. We are going to add here the event. We are going to assign the enemy chart here. Choose a function from our enemy, from enemy, and we are going to choose the perform attack function so that we can actually perform the attack function. And what is left is to make sure that our player script, we can open it up quickly. So we will need to make sure that this player script implements the eye hittable. So we are going to implement it in the next video. See you there. In the previous video, we have implemented the enemy attack script, but since our player doesn't have eye hittable on it, we cannot really perform the hit. So what we will want to do first, let's go to our player in the hierarchy and let's choose our player script. It is at the bottom. Let's minimize the agent input and agent movement. Let's click those three dots near the player script and let's edit this script. Great. What we want to do here is let's add, after the agent in the class definition, we are going to add eye hittable. And we will need to click on it, Alt-Enter, and implement interface so that we can access it. So we have our health, and this is a property, and we have our get hit. First, we may want to add to the health a field serialized field attribute so that we can expose it in the editor. So serialized field. Great. And next, what we will want to do is we will want to add to the get hit some code. So let's, first of all, what we can do now is simply call health minus minus, and we can call debug.log, let's call it enemy hit player, or maybe player hit, since it can be bullet that hit player. So any player hit in the get hit method. Now we should be able to call this get hit or invoke it from our enemy attack script. So let's go back to Unity and let's try playing the game. Let's go near the enemy and nothing happens because I have made a mistake in the code. Let's stop it. Let's go back to our script folder, enemies, and let's open up the enemy script. Okay. And I have implemented this dead flag, but I'm only calling the perform any attack if the enemy is dead, and obviously it is not what I wanted. So we are going to check if it is equal to false. And now we can save it, and let's go back to Unity. Great. And now we can press play. We can run towards the enemy, and if enemy is close enough, it will call player hit, player hit, player hit. And if we go to our player and let's see the health is being decreased. So that is great. We are almost there for our player. So let's go back to our player. So I think we need to go to our assets, scripts, player, and let's open up the player script. Great. And what we can see here is that we have those two events that are not exposed in the editor. So let's add to those on die and on get hit events a field. We are going to the attribute field serialized field, so we can see them in the inspector and we can assign to them. And in get hit, we want to check, as we did for our enemy, if our health is less or equal to 0, we will want to perform different operations. So player hit is can be only played, or actually we can delete this debug.log statement. What we will want to do is call on get hit, and a question mark to say if anybody is listening, dot invoke. And again, health less than 0, we are going to add on die. Again, question mark dot invoke. And again, we can implement a bool flag here. So under health, let's create private bool dead equals false. And again, we can see if our player is not dead. So if in get hit dead equals false, only then we will want to decrease the health. And if health is below 0, we want to call on die and dead equals true. Great. So now we can assign some functionality to those events and we can perform some actions. So what we will want to do is, let's save it, let's go back to Unity. Great. What we can see in our player that it should have a agent sounds, and we have not assigned sounds to it. So let's quickly do that. We are going to choose the hit clip, select the cog icon, and we are going to search for underscore female, and we have female hit. And for the death sound, again underscore female and female death. I do not know which one of the sounds we are going to use for the voice line, so for now we have only those two sounds. But what we can do is go to our player and assign on die functionality. Let's drag our agent sound, and we are going to perform this agent sounds, and let's call player death sound and get hit, add an event player, or actually not player but the agent sounds, and let's play agent sounds and player hits, play hit sound. Great. Now before we can test it, let's go to our agent sounds, choose the female death, select it in the project section. Let's see, it is about 2 seconds. So what we can do is go back to our scripts folder, player, and let's reopen the player so we can implement this the same kind of coroutine. Before our player dies, it will finish playing the death sound. So let's open the player script. Great, we are inside our player script, and what we will want to do is we are going to create enumerator death coroutine. Okay, and this is a temporary solution, so we are going to yield return new wait for seconds. Let's wait 0.2 second, and we are going to call destroy game object. Okay, we need to add 0.2f, and we are going to simply return get hit that is true, and we are going to call start coroutine, and we are going to pass the death coroutine. Okay, now we should be good to go. Let's save it. Let's go back to Unity. Great. Let's choose our player. Let's make sure that the health is something like 2. Let's press play and let's see if our enemy can kill our player. And we can see that we have some errors, so we will need to fix them. And what we will want to do is we will want to go to the assets, scripts, enemies. Let's open up the enemy brain. Great. Let's slide it down, and what we will want to do is if target equals null, we are going to call on movement press key invoke vector 2 zeros to stop moving. Else, if target is not null, only then we are going to call current state.update. Let's save it. Let's go back to Unity. Okay, now if we press play, we will see that if our enemy attacks us and we die, we will still not be able to do anything, and the enemy will stand still. So that's great. That means that we have concluded our enemy AI behavior. So we could probably spawn multiple enemies here and perform the attacks on our player, and we could kill our enemies, and it should work fine. But the problem is that our player or our player death is a little bit dull. It only disappears and nothing happens. Just as well, our enemy dies. We can hear sound, but it only disappears. We have no idea if it has disappeared because it is invisible or we have killed it. It is too little feedback for the player, and we have no, for example, feedback when we are shooting those walls. We do not know what happens with the bullets, as well as we could have this issue where we can shoot the bullets outside of the area. So we will need to fix it as well. So we will need to add some more colliders here. So in the next section, we are going to fix little bugs like this that we can shoot outside of the area, and we are going to focus on adding some more feedback, more audio and visual feedback to our functionality for our game, so that we will be able to define clearly that our enemy has died, our player has died. We are going to add some animations, some shaders, so it all looks much better. So this will be the part about the juiciness of the game. I hope you are enjoying this course so far. See you in the next section.